Alright, this is the curvature rebuild called SuperComb. This was a rebuild of the original Rhino idea, or whatever the popular CAD convention of comb curvature. This allows for the curvature to be toggled to black and white for the minimum and medium, and different color palettes for the different radiuses. This allows for the change in the density. These dials could also be sliders in Rhino, but this OSC interface makes it a little bit easier. The controls are all mapped via this legend right here over to the physical dial box. So for example, comb density can be dialed. Comb length can be dialed. You can see by the effect on the turntable, there's a slight recalculation time, but it's very minimal. The width of the lines can be toggled as well, not toggled, but from very fine lines to full, almost full. We can bump the density up so we get a full spectrum view. Let's go to color of the minimum and maximum curve radii. All right, let's drop the comb width back down again. Density back down again a little bit, just for less busyness. This all is live, so when elements are adjusted, this controls now the actual drive curve. So when the back is adjusted, this allows for also this can be fine adjusted to fine tune in a curvature by just looking at the colors as well as the lengths and matching the curvature along the back of the helmet. Similar to the front. Let's go the other way. Let's reduce that magnitude of that throw, and now we get an even curvature off the front. So what is the curvature? Well, we have labels now. We can go back to curvature. We can show the radius labels. These give radiuses along the helmet in various places. 97 millimeters, 154 millimeters, and the density of these labels can also be adjusted. It can be cranked right up, so you've got lots of specifications. That's obviously overkill, but there's a couple hundred variations, or not, couple hundred locations along the curve that this can be denoted. Various different curves can be toggled in. Here is the outline of the curve. This is the outline of the helmet. Let's take that back down. Let's reduce these numbers. Let's reduce the comb density. And now we can get different sort of views of where the curvatures are on the helmet. Again, this doesn't affect the performance at all. It's all written in Python. The Python is assisted, well, not assisted, but greatly written by AI. There's probably about 30 different iterations to this coding, adding features after thinking about them for a while. The curvature can also be the palette, the color palette display can be normalized. Right now, no matter how the curve changes, or if there's two different curves, the colors are dependent on the minimum and maximum radius. If it's fixed, this now becomes fixed to a minimum and maximum radius. So now all the colors represent the same curvature in the display. So at 200, around 200 is yellow, and it's yellow on both curves, even though the curvatures overall are different. These two dials set the minimum and maximum range. It's a very high maximum. We don't have that kind of curvature, and this is a lower maximum. So now we have a curvature display and palette that's fixed to given radiuses. Here's bumping up the minimum. That's a little bit, we're going to need to display that here. This is actually, you can see with the line, the minimum is now 50 millimeters, and the maximum is 215. So that's the display there. All right, I think that just about covers it. This is all included in a GH file along with this post. Meshes can be toggled out. Meshes can be displayed in various materials. Let's toggle off the curvature labels, toggle down the scale, and get an idea there. This can also be used obviously in conjunction with surface analysis, which was done in a different video, but there's also the ability to see the curvature and adjust all of this, of course, in real time. So if the taper in the back goes down, you get a lot tighter taper. Let's reduce that to a minimum, almost a point in the back. It's a very pointed rear of the helmet. The length can be changed, greatly adjusted, and everything stays intact. Bring that back into a normal thing. Of course, all these dials can be adjusted at the same time. These dials allow for precision down to the 100th of a millimeter if that's so desired, by just turning them very slowly. All right, that's the SuperComb preview, May 2025. Feedback is appreciated.